Hello everyone, I'm Prathyusha Sangam, also known as Prathi. I'm a data scientist at West Farmers Chemicals, Energy and Fertilizers. Today, I'd like to share my machine learning journey and I hope to inspire some of you to dive right into it. So here's an outline of what I'll be talking about today. I'll begin with a brief introduction of my current work as a data scientist and what inspired me to get into this field. I'll share some tips on how you could start, grow, and thrive as a data scientist or a machine learning engineer. I will also share some examples of how diving in headfirst opened up exciting opportunities and made my machine learning journey enriching. As I mentioned earlier, I'm a data scientist at WestCef. WestCef operates 8 businesses in Australia. So far, I've worked on projects for Clean Heat's natural gas and electricity products, AGR's sodium cyanide plant, and CSBP's nitric acid plant. The best part about working in WestCef is the varied exposure to different businesses, domains, and analysis types. My projects fall into the categories of business intelligence, which involves building dashboards to support operations, customer analytics, which is to understand customer behavior through clustering, segmentation, and prediction, and plant analytics, which is to use huge amounts of industrial IoT data to help automate and optimize operations in chemical plants. The types of analysis I work on can be broadly divided into these 4. The first one is descriptive. It is the simplest form of analytics. The purpose is to summarize the findings to understand what's going on. It basically involves the usage of descriptive statistics such as averages and percentages on existing data. Though simple, it's an important step to make raw data understandable to various stakeholders and managers. The second one is explanatory, also known as diagnostic analysis. It is used to determine why something happened. It uses techniques such as drill down, data mining, and correlations. It helps understand the root causes of past events and determine what factors contributed to the outcome. You could place these two under EDA, that is exploratory data analysis, which is crucial for the next 2 stages. The third type of analysis is predictive. This is where machine learning comes into picture. It uses statistical models and machine learning techniques, both classification and regression, to predict what is likely to happen. The fourth type is prescriptive. This involves optimization, that is, how to achieve the best outcome given a set of constraints. In my opinion, to be a successful data scientist, you must be able to do all 4 types of analysis. So, how did I get into data science? I started my career as a software developer in an IT consultancy firm in 2012. I worked on web development projects for several organizations in e-commerce, telecom, and banking. Typically, these organizations produce large amounts of transactional data. I often heard about how this transactional data was used to identify patterns in customer behavior. Some use cases I came across were recommendation systems in e-commerce, fraud detection in banking, and product bundling strategies in telecom. I was intrigued by the concept of data-driven decision making, and it stuck with me. Around the same time, I found the love of my life. I quit my job as a software developer and moved to China with my husband. I had a 6-month gap in my career, and I used this time to explore data science. I spent time learning Python programming and machine learning online. I decided I wanted to go a step further and get a master's in this field. I graduated with a Master of Data Science from University of Western Australia. I must admit, I followed a pretty conventional career pathway into this field. In my 4+ years in data science, I can say that not everyone needs to follow the same path. So, how to get started with machine learning without formal education? Well, data science is an interdisciplinary field. It is about obtaining knowledge by using the intuition of domain expertise, validating insights using maths, and automating this process using computers. So basically, you need to know maths and coding to build machine learning algorithms. When you Google for the maths requirements for ML, calculus, linear algebra, and statistics consistently come up. For starting out, your knowledge of basic high school maths should do. You need to be familiar with statistics. You will need calculus and linear algebra at a later stage where you want to understand how algorithms work under the hood. Knowing how to code is very important. Learning Python is a great way to start programming. Python is very easy to learn and is a popular choice for machine learning. When you're starting out, I highly recommend doing some research. Do some light reading on the history of ML, Industry 4.0, the applications of machine learning and its importance, as well as data ethics. It will help get some background and appreciation for the field. Follow online courses. I suggest going with something basic to start with. Courses that cover advanced topics in much depth may feel a little overwhelming at first. Aim at incremental gains. As a beginner, I recommend to focus on breadth and not depth. Try different algorithms and different types of problems. Start writing code now. Jump into it. As soon as you learn about an algorithm, I say get hands on. This will give you a huge amount of instant validation and the push to keep going. Try Jupyter notebooks to test things out. You can pick ML tasks on platforms like Kaggle. Engage with a broad range of data sets to get accustomed to thinking about different domains. For example, you could look at medical, financial, sales, climate, or even sports data. Most importantly, have fun. Choose a domain that interests you. How to grow. Once you get a hang of things, take it to the next level. Start competing online. Several platforms like Kaggle, Driven Data, AI Crowd host competitions. Also keep an eye out for hackathons. Try to join a group and solve a problem. Collaborate with people from different fields. In addition to technical skills, that is the maths and coding side of things, you learn problem solving skills this way. To be a successful data scientist, you need to know how to ask the right questions and find the key drivers. Pick a project of your own. You could build and deploy a model using Amazon SageMaker. A big shout out to Mike Chambers, who recently shared a project on classifying Lego bricks. Do fun projects like this. It'll keep you engaged and help you learn. Now that you have learned the technical and non technical skills to be a good data scientist or a machine learning engineer, how do you accelerate your career? How do you thrive? You must be passionate, thorough with the basics, and willing to constantly learn and evolve. A great addition to your profile is to get certified. For example, you can do the AWS ML Specialty Certification. You could sign up to newsletters like Towards Data Science, KD Nuggets News, Towards AI, and Medium, or follow the latest research papers on paperswithcode.com. Give back to the community. I'm personally very passionate about supporting women in technology. I also spend time mentoring aspiring data scientists at the University of Western Australia through industry panels and events. To succeed, learn, grow, and repeat. Continue participating in competitions. Keep trying things that you have never done before. I'd like to share an example of why diving deep is a recipe for success. Last month, I came across this session called AWS Deep Racer League organized by SheBuilds. For those who aren't aware, Deep Racer is the world's first global autonomous racing league driven by reinforcement learning. I joined the session to learn something new. I never worked on reinforcement learning before. It looked like fun and it was free, so why not? We started off with an introduction to ML and reinforcement learning (RL), followed by Deep Racer overview and all the basics we needed to build the racing model. We were taught how to use the Deep Racer console and how to set up a vehicle and how to write the reward function using the various hyperparameters. We were given a week of hands-on time to work on our models. We got tips and a lot of support on a Slack group throughout the week. At the end, we submitted our models to the community race. I think this session was the perfect setup to learn ML. We immediately put our skills to use as we learned it. It was fun and rewarding. I work full time, so I had to capitalize on my evenings. During my hands-on week, I did research on the hyperparameters, what people have done in the past, and went through the material shared. I skimmed through information with a focus on breadth. I didn't have to be an expert in reinforcement learning to do this. My focus was primarily on how to use the hyperparameters to write the reward function, as everything else is basically managed by AWS. I spent time whiteboarding, buddied up with my husband to bounce off ideas. I made use of the resources, trained multiple models with variations. I was in it just for the fun, but I did it with passion and focus. What happened next was something I didn't expect at all. I came eighth in the virtual race. I won the final race, which was on a physical car. Along with some great Amazon Echo prizes, this gave me entry to the Deep Racer League at reInvent 2020. Winning is awesome, but the biggest takeaway for me are the opportunities that opened up, including today's talk. I found several mentors in the AWS community. It helped me find a new passion in reinforcement learning. It has also gotten me thinking about the applications of reinforcement learning at my work. Before I sign off, I would like to emphasize, don't wait to memorize the theory. Get hands-on with ML. Start coding right away. ML is an ocean, but there are numerous resources and lots of support. You can do this. Focus on small wins and incremental growth. Be passionate, share, learn, and grow. Success will follow. Thank you.